The German tanks of World War II have achieved almost mythical status in popular culture. The Tiger, the Panther, the King Tiger. These names evoke images of unstoppable steel monsters that struck terror into Allied forces. Countless books, documentaries, and films have portrayed German armor as technologically superior, brilliantly engineered, and devastatingly effective. But here's the uncomfortable truth that often gets overlooked. German tank designs were fundamentally flawed, and these flaws contributed significantly to Germany's defeat. Despite their fearsome reputation, German tanks failed catastrophically under real combat conditions. This is the story of how over-engineering, logistical nightmares, mechanical unreliability, and strategic miscalculations turned what should have been Germany's greatest advantage into one of its most significant liabilities. To understand why German tanks failed, we need to start at the beginning. When World War II began in September 1939, German armor was actually inferior to that of its opponents. The Panzer D and Assault were little more than training tanks pressed into combat service, armed with machine guns or small 20 mm cannons. Even the Panzer III and IV, which would become the workhorses of the Panzer divisions, were not particularly impressive compared to French or British tanks of the period. The French Char B1 and the British Matilda II had thicker armor and were nearly invincible to German anti-tank weapons in 1940. So how did Germany achieve such spectacular success in Poland and France? The answer wasn't superior tanks, it was superior tactics, training, and operational doctrine. The Germans concentrated their armor into dedicated panzer divisions, used combined arms effectively, and employed radio communication that allowed for unprecedented coordination. Meanwhile, the Allies dispersed their often superior tanks in small packets to support infantry, negating their advantages. Everything changed on the 22nd of June 1941, when Germany invaded the Soviet Union in Operation Barbarossa. German tankers received a rude awakening when they encountered the Soviet T-34 medium tank and the KV-1 heavy tank. The T-34 in particular was a revelation. It combined sloped armor, but was effectively impervious to most German tank and anti-tank guns. A powerful 76 mm gun, wide tracks that gave excellent cross-country mobility, and a diesel engine that was more reliable and less flammable than German gasoline engines. German tank crews were shocked and demoralized. General Paul von Kleist called the T-34 the finest tank in the world, and Panzer General Friedrich von Mellenthin wrote that the T-34 had a vast superiority over any tank we had in 1941. The German response to this shock would set the stage for the ultimate failure of German tank design. Rather than adopting the T-34's philosophy of balanced, practical design, German engineers went in the opposite direction toward increasingly complex, heavy, and over-engineered vehicles. The first major response was the Panther tank, designated Panzerkampfwagen Ver, ordered into accelerated development in 1941 and rushed into production by 1943. The Panther was intended to combine the best features of the T-34 sloped armor and a powerful gun with superior German engineering. On paper, it was impressive, a 75 mm high-velocity gun that could penetrate any Allied tank at long range, well-sloped frontal armor, and reasonable mobility. But the Panther became the poster child for German over-engineering. It weighed 45 tons, making it a heavy tank masquerading as a medium tank. Its Maybach HL-230 engine was temperamental and prone to catching fire. The tank's complex transmission and final drive were woefully inadequate for its weight and broke down with alarming frequency. Early Panthers had a life expectancy measured in kilometers, not months. When the Panther debuted at the Battle of Kursk in July 1943, it was a disaster. Of the 200 Panthers committed to the offensive, more broke down than were knocked out by enemy fire. But if the Panther represented over-engineering, the Tiger tank represented it to an even greater extreme. The Tiger I, which entered service in late 1942, was a genuinely formidable weapon when it worked. Its 88 mm gun could destroy any Allied tank at ranges they couldn't hope to match, and its thick armor made it nearly invulnerable from the front. A single Tiger could dominate a battlefield, and Allied tankers learned to fear it. But the Tiger was a maintenance nightmare. It weighed 57 tons, making it one of the heaviest tanks of its time. This weight stressed every component. The overlapping road wheel design, while providing a smooth ride, was complex and prone to problems. In winter, mud and snow would freeze between the wheels overnight, immobilizing the tank until the ice could be chipped away, a process that could take hours and leave crews vulnerable. The Tiger consumed fuel at a prodigious rate, managing only about 1.3 kilometers per liter on roads and even less cross-country. Its Mavic engine was powerful but temperamental. The tank required extensive maintenance after relatively short operating periods. Tiger production numbers tell their own story. From 1942 to 1944, Germany produced only 1,347 Tiger V tanks. Compare this to Soviet production of over 57,000 T-34 Serv during the same period, or American production of nearly 50,000 Sherman tanks. Each Tiger required approximately 300,000 man-hours to build, roughly twice that of a Panther and 3 times that of a Panzer IV. The Tiger was less a mass-produced weapon and more an artisanal product, handcrafted by skilled workers who could have been building 2 or 3 more practical tanks in the same time. This wasn't just inefficient. It was strategic madness for a country fighting a multi-front war against opponents with vastly greater industrial capacity. German tank designers seem to have forgotten that wars are won not by individual technical superiority, but by numbers, reliability, and logistics. You can have the best tank in the world, but if you can only field a handful of them, if they break down constantly, and if you can't supply them with fuel and ammunition, they become expensive paperweights. Then came the King Tiger, or Tiger II, which entered service in 1944. If the Tiger TIE was over-engineered, the King Tiger was over-engineering taken to absurd extremes. Weighing 68 tons, it was the heaviest tank to see regular service during World War II. Its armor was immensely thick 180 mm min on the turret front, and its long 88 mm gun could penetrate any Allied tank from virtually any range and angle. In the rare instances when a King Tiger was properly positioned, well supplied, and mechanically functional, it was devastating. But those instances were remarkably rare. The King Tiger was a mechanical disaster. Its engine was the same Maybach HL-230 used in the Panther, a 700 horsepower unit that was already struggling to move the Panther's 45 tons. In the King Tiger, which weighed 50% more, it was hopelessly inadequate. The tank was painfully slow, with a maximum road speed of just 41 kilometers per hour that it could rarely achieve. Cross-country speed was a glacial 15-20 kilometers per hour. The King Tiger's weight created cascading problems. Its transmission was in a constant state of distress and failure. Final drives broke regularly. The overlapping road wheel design was even more problematic than on the Tiger IV. Fuel consumption was catastrophic. The tank could travel less than 1 kilometer per liter of fuel. Given that Germany was suffering from chronic fuel shortages by 1944, this was crippling. Most damaging of all, the King Tiger was simply too heavy for most bridges. German bridge-laying equipment couldn't handle it, and few existing bridges could support its weight. This meant King Tigers either had to ford rivers, a time-consuming and risky process, or take lengthy detours to find suitable crossings. Tactical flexibility, one of armor's greatest advantages, was completely negated. In combat, King Tigers were frequently abandoned by their crews, not because they were destroyed, but because they broke down or ran out of fuel. Germany produced only 489 King Tigers during the entire war. Each one represented a massive investment of resources that could have built multiple more practical vehicles. Let's talk about the elephant in the room. Complexity. German tanks were masterpieces of engineering, but that was precisely the problem. They were too complex for the conditions under which they had to operate. Take the transmission systems, for example. German tanks used sophisticated but fragile transmissions with multiple gear ratios that required skilled operation. Under ideal conditions, operated by well-trained crews with proper maintenance support, they worked adequately. But war doesn't provide ideal conditions. Crews were increasingly rushed through training as the war progressed. Maintenance facilities were bombed, spare parts were in short supply, and tanks operated in mud, snow, desert sand, and other harsh conditions. Every additional component, every clever engineering solution, every precision machined part was another potential point of failure. The Panther's final drive, for instance, was a complex piece of engineering that was chronically inadequate for the tank's weight. It was not uncommon for Panthers to throw a track or suffer final drive failure after just 150 kilometers. This wasn't an occasional problem, it was endemic. Compare this to the Soviet T-34. Soviet engineers deliberately designed their tanks for rough handling by poorly trained crews in terrible conditions. The T-34's transmission was crude and difficult to operate, with a clutch so heavy that drivers sometimes had to use a hammer to shift gears. But it was simple and robust. When something broke, it could often be repaired in the field with basic tools. The tank's wide tracks and powerful engine gave it excellent mobility in mud and snow where German tanks bogged down. Most tellingly, the T-34 could be produced quickly by semi-skilled labor, including women and teenagers with minimal training. A T-34 required approximately 3,000 man-hours to build a tenth of what a Tiger needed. Was the T-34 as sophisticated as German tanks? No. Could it match a Panther or Tiger in a one-on-one duel? Usually not. But the T-34 could be produced by the tens of thousands, could operate reliably in terrible conditions, could be repaired quickly, and could be crewed by hastily trained personnel. In other words, it was exactly what a war-winning tank needed to be. The American Sherman tank followed similar design principles. The Sherman is often dismissed or ridiculed, particularly in comparison to German heavy tanks. There's even a persistent myth that it took 5 Shermans to knock out one German tank, and that Sherman crews faced near certain death. This myth is largely nonsense, but it's proven remarkably durable. The Sherman had several enormous advantages that more than compensated for its shortcomings. It was reliable, remarkably so. Shermans could operate for extended periods with minimal maintenance. They rarely broke down, and when they did, repairs were straightforward. The tank used a proven commercial engine design that any mechanic could understand. It had a reliable transmission, a reliable suspension, reliable everything. This reliability meant that when a Sherman unit went into battle, commanders knew their tanks would actually function. The same could not be said of German units, where operational readiness rates were often shockingly low. The Sherman was also produced in staggering numbers. The United States built nearly 50,000 of them. This mass production was possible because the Sherman was designed from the outset for ease of manufacture. It used standardized parts, had excellent automotive reliability, and could be produced by automobile factories converted to war production. Assembly line techniques that Henry Ford had pioneered were applied to tank production. But the Sherman's greatest advantage was logistical. It was compact enough to be shipped efficiently across oceans. It could fit through standard transport infrastructure. It was light enough for most bridges. It used a gasoline engine that, while more flammable than diesel, ran on fuel that was readily available in the U.S. supply chain. And crucially, the Sherman was easy to maintain and repair. American armored divisions had extensive maintenance support, and the Sherman was designed to take advantage of it. Entire engines could be swapped out in the field in a matter of hours. Tracks could be replaced quickly. The tank was designed around the understanding that it would be maintained in the field by soldiers who were mechanics, not engineers. Let's examine operational readiness rates, because this is where German tank design failures become devastatingly clear. A tank that isn't running might as well not exist. In late 1944, during the Battle of the Bulge, German operational readiness rates for tanks were often below 50%. Some units reported that fewer than 30% of their tanks were operational at any given time. This meant that a panzer division with 100 tanks on paper might only be able to field 30 or 40 for an actual battle. The rest were broken down awaiting parts, undergoing repairs, or had been cannibalized to keep others running. Allied operational readiness rates, by contrast, were typically 70–90%. This massive difference in availability multiplied the existing numerical advantages the Allies enjoyed. If Germany had 1,000 Panthers but only 400 were operational, while the Americans had 5,000 Shermans and 4,000 were operational, the actual battlefield disparity wasn't 5–1, it was 10–1. German design philosophy had created tanks that spent more time in repair shops than in combat. Fuel consumption was another critical failure of German tank design. As the war progressed, Germany faced increasingly severe fuel shortages. The Allies systematically destroyed synthetic fuel plants and captured oil fields. By 1944, the Wehrmacht was desperate for fuel. Yet German tanks were prodigious fuel consumers. The King Tiger's consumption has already been mentioned, but even the Panther was inefficient, managing only about 1.5 kilometers per liter under ideal conditions and far less in combat. This created absurd situations where powerful German tank units sat immobile, not because they were defeated, but because they had no fuel. During the Battle of the Bulge, Germany's last major offensive in the West, entire tank columns ground to a halt when they ran out of fuel. German planning had depended on capturing American fuel supplies, which tells you everything you need to know about how divorced from reality German strategic thinking had become. Meanwhile, Allied tanks, while also fuel-hungry by modern standards, operated within supply systems that could actually support them. Training and doctrine also played crucial roles in German tank failures. Early in the war, German tank crews were superbly trained, often with years of experience. By 1944, this had changed dramatically. The casualties suffered on the Eastern Front, combined with Germany's shrinking resource base, meant that replacement tank crews received abbreviated training. Operating complex tanks like the Panther and Tiger required significant skill. The Panther's transmission, for instance, demanded careful handling to prevent premature failure. Poorly trained crews could and did destroy their own tanks through improper operation. Furthermore, German doctrine evolved in counterproductive ways. There was an increasing emphasis on firepower and armor protection at the expense of mobility and reliability. This reflected a defensive mindset, building tanks to fight from prepared positions rather than for the mobile warfare at which the panzer forces had once excelled. By 1944, Germany was losing the war and knew it. German tanks increasingly reflected a desperate attempt to achieve tactical superiority to compensate for strategic collapse. There were also bizarre design decisions that defied common sense. Consider the Porsche-designed Tiger, often called the VK45.01 Pre. Ferdinand Porsche, who enjoyed Hitler's patronage, designed a heavy tank that used a gasoline-electric drive system and internal combustion engine-powered generators that drove electric motors. This system was complex, expensive, used scarce copper, and was prone to catching fire. It was rejected in favor of the Henschel Tiger design, but 90 of the Porsche chassis had already been built. Rather than scrap them, they were converted into the Ferdinand tank destroyer, also known as the Elephant. The Ferdinand was heavily armored and mounted a powerful 88 mm gun, but it had no defensive machine gun and almost incomprehensible oversight. This meant that once enemy infantry got close, the Ferdinand's crew was helpless. Ferdinands were repeatedly knocked out or captured by Soviet infantry. This wasn't just a design flaw, it was design negligence. The Germans also developed numerous other problematic designs. The Maus, or Maus, was the heaviest fully enclosed armored fighting vehicle ever built, weighing 188 tons. Only 2 prototypes were completed, and neither saw combat. The Maus was so heavy that no existing bridge could support it, so it was designed to drive across river bottoms while snorkeling. The absurdity of dedicating scarce resources to such a project in 1944, when Germany was collapsing on all fronts, beggars belief. There was also the Jagdtiger, an even heavier tank destroyer mounting a 128 mm gun. It weighed 71 tons and suffered from all the problems of the King Tiger, magnified. These vehicles represented a fevered obsession with technical superiority, divorced from strategic reality. Germany didn't need super-heavy tanks that could destroy any opponent in single combat. It needed reliable, mass-producible vehicles that could be supplied and maintained under increasingly difficult conditions. The Germans built impressive engineering showcases while the Allies built war-winning weapons. The strategic implications of German tank design failures were profound. By 1943, Germany had lost the strategic initiative and would never regain it. From that point forward, German forces were reacting to Allied offensives on multiple fronts. This required mobile, reliable armored forces that could rapidly redeploy to threatened sectors. Instead, Germany had heavy, fuel-hungry, unreliable tanks that were often immobilized by mechanical failures or lack of fuel. The Panther and Tiger were designed for offensive operations where they could use their superior firepower and armor at range, but by late 1943, Germany was almost entirely on the defensive. Tanks that could have been excellent in breakthrough operations were instead being used in desperate defensive battles where their weaknesses were maximized. A Panther's transmission might fail after 150 kilometers of road marching, but it could easily fail after 50 kilometers of combat operations in difficult terrain. This meant that German tank units suffered constant attrition not from enemy action, but from mechanical failures. Logistical nightmares plagued German armored forces. Spare parts were in chronic short supply. By 1944, Allied bombing had devastated German industry, and what production remained had to be dispersed to avoid destruction. This meant that spare parts production was scattered and insufficient. A Panther unit needing final drives might wait weeks or months for replacements, if they arrived at all. Meanwhile, the tanks sat useless. The Germans attempted to address this through cannibalization, stripping parts from irreparable tanks to keep others running. This created a death spiral where the number of operational tanks constantly decreased even without combat losses. Transport infrastructure was also collapsing. Allied air superiority meant that moving tanks by rail was increasingly dangerous and difficult. Rail lines were bombed, bridges were destroyed, and trains were strafed. Moving a panzer division from one front to another, which had once taken days, now took weeks, and resulted in significant losses en route. There's an interesting psychological component to German tank design philosophy that deserves examination. German engineers and military leaders became intoxicated with technical sophistication. There was a belief, almost a fetish, that German engineering superiority could overcome material disadvantages. This was delusional. Wars are ultimately won by economics and production. No amount of engineering sophistication can compensate for being outproduced 10-1 or 20-1. The Soviet Union and United States understood this. They built tanks that were good enough, that could be produced in vast numbers, and that worked. German engineers kept trying to build perfect tanks, and in doing so built expensive, unreliable, over-engineered machines that couldn't be produced in sufficient numbers. There was also an element of arrogance. German tankers and commanders often expressed contempt for Allied tanks, particularly the Sherman. This contempt was sometimes justified in one-on-one combat, but it missed the larger picture. The Sherman's crew might lose a single engagement with a Panther, but Sherman units won campaigns. The impact of Allied air superiority cannot be overstated. By 1944, Allied aircraft dominated the skies over Western Europe and increasingly over Germany itself. This had devastating effects on German armored operations. Tanks moving during daylight were subject to constant air attack. Allied fighter bombers, particularly the American P-47, Thunderbolt, and British Typhoon, specialized in ground attack missions. While their actual tank kill numbers were often exaggerated, they didn't need to destroy tanks to render them useless. Near misses could damage optics, tracks, or other components. More importantly, constant air attack forced German tanks to move only at night or under heavy weather, drastically reducing operational flexibility. Air attacks also devastated supply columns, fuel depots, and repair facilities. German tanks might survive combat engagements, only to be destroyed while stationary by air attack. Heavy tanks like the Tiger and King Tiger were particularly vulnerable because their slow speed and massive size made them easy targets. Once spotted by aircraft, they often couldn't maneuver away quickly enough. Compare German tank development to that of the Allies, and the contrast is striking. The Americans continuously refined the Sherman throughout the war. They upgraded the gun from a 75 mm to a 76 mm, improved armor, tested different engines, and even developed variants like the Sherman Firefly with a British 17-pounder gun. But these were incremental improvements to a proven, reliable platform. The Americans didn't radically redesign their tanks mid-war because the Sherman, despite its flaws, worked. It could be produced en masse, it could be shipped globally, it could be maintained, and it was reliable. The Soviets similarly refined the T-34, upgrading it from the T-34-76 to the T-34-85, with a larger turret and more powerful gun. But they maintained the basic design philosophy: simple, robust, mass-producible. They also developed the IS-2 heavy tank, which was genuinely impressive, well-armed, well-armored, and far more reliable than German heavy tanks. The British, meanwhile, struggled with tank design but eventually produced the Comet, an excellent cruiser tank that appeared near war's end. One must also consider the human cost of German tank design failures. Tank crews paid the price for engineering hubris. Panthers that caught fire because of engine problems killed their crews. Tigers abandoned due to mechanical failure left their crews stranded behind enemy lines. King Tigers that ran out of fuel forced crews to destroy their own vehicles and retreat on foot. Beyond direct casualties, there was the psychological toll. German tank crews knew their vehicles were unreliable. They knew they might be abandoned by their tanks at any moment. This affected morale and combat effectiveness. Contrast this with Allied crews, particularly American ones, who had enormous confidence in their tank's reliability. A Sherman crew knew their tank would start, would run, and if damaged, could probably be repaired. This confidence allowed them to focus on fighting rather than worrying about mechanical failure. In the intimate environment of a tank, where 5 men depend on each other for survival, trust in one's vehicle is paramount. German designs eroded that trust. Let's examine some specific battles to see how these design failures played out in practice. At the Battle of Kursk in July 1943, Germany launched its last major strategic offensive on the Eastern Front. The attack incorporated significant numbers of the new Panther tank, which was supposed to provide a decisive advantage. Instead, Panthers broke down in enormous numbers. Of 200 Panthers committed to the offensive, approximately 162 suffered mechanical failures. Only about 38 were lost to enemy action. The Panther's engine was prone to fires, its transmission was inadequate, and its suspension broke under stress. Many Panthers never reached the battlefield. Those that did often broke down during combat operations. The few that remained operational were admittedly formidable, but far too few to affect the battle's outcome. Kursk demonstrated that technical sophistication without reliability was worse than useless. It gave a false sense of capability that led to strategic miscalculation. Germany committed its precious armored reserves to an offensive partly on the assumption that the Panther would provide a decisive edge. When the Panthers broke down, the offensive failed, and those reserves were lost. The Battle of the Bulge in December 1944 provides another stark example. This was Germany's last major offensive in the West, a desperate attempt to split Allied forces and capture the vital port of Antwerp. The offensive depended on rapid movement by armored spearheads, particularly SS Panzer divisions equipped with Panthers and King Tigers. It failed catastrophically, and German tank design played a significant role in that failure. Road conditions were poor, and many German tanks broke down even before engaging the enemy. Fuel shortages were crippling. Some German tank units advanced only as far as their initial fuel load allowed, then sat immobile. Kampfgruppe Paper, a strong SS formation, included some of Germany's most powerful tanks but was ultimately forced to abandon most of them when they ran out of fuel. The heavy King Tigers proved almost completely useless. Their slow speed meant they couldn't exploit breakthroughs. Their weight made them road-bound and their fuel consumption was disastrous. Meanwhile, American forces, after initial surprise, responded with rapid redeployments of Sherman-equipped armored divisions. These reliable, mobile American tanks counterattacked effectively and ultimately defeated the German offensive. Even in defensive battles, where German heavy tanks should have excelled, design flaws undermined effectiveness. In Normandy in June-August 1944, German panzer divisions faced enormous challenges. Allied air superiority made daytime movement nearly suicidal. Fuel and ammunition shortages were chronic, and mechanical failures were constant. The Panther-equipped divisions suffered appalling attrition rates, much of it from non-combat causes. Units would report 60 or 70 operational Panthers one day, and 30 or 40 the next, not from combat losses, but from breakdowns. Tiger units, while deadly when properly positioned, were often immobilized by lack of fuel or mechanical problems. German tankers frequently fought brilliantly with what they had, but they were let down by their equipment. Meanwhile, Allied tanks kept coming. A Sherman destroyed today would be replaced tomorrow. Crews knew this and took confidence from it. German crews knew that their Panther would not be replaced, that parts were unavailable, and that the overall situation was hopeless. This affected combat performance in ways that are difficult to quantify, but undoubtedly significant. The question arises, could Germany have done things differently? The answer is clearly yes, though whether different tank designs could have changed the war's ultimate outcome is doubtful. Germany faced overwhelming material disadvantages that no amount of clever engineering could overcome, but better design choices could have made German forces more effective and prolonged the war. If Germany had focused on producing improved Panzer IVs and a more reliable, lighter version of the Panzer, they could have fielded far more tanks. If they had designed for ease of manufacture, reliability, and logistical support, rather than technical superiority, their armored forces would have been more effective. There were voices within the German military who argued for such approaches. General Heinz Guderian, the father of German armored warfare, repeatedly argued against overcomplicated designs and for mass production of simpler vehicles. He was largely ignored. The German military-industrial complex, under pressure from Hitler's unrealistic demands, and driven by inter-service rivalries and political considerations, continued producing over-engineered behemoths. There's also the issue of resource allocation. Every Tiger that was built consumed resources that could have produced 3 or 4 Panzer IVs or Stog 3 assault guns. The Stog 3, incidentally, was one of Germany's most successful armored vehicles. It was essentially a turretless tank with a fixed gun, simpler and cheaper to produce than a turreted tank, and highly effective in defensive combat. Stog SOGSOs had excellent operational readiness rates because they were relatively simple and reliable. Germany built over 10,000 of them, and they accounted for a disproportionate number of enemy tank kills. This suggests that simpler designs could have been more effective. Had Germany devoted the resources spent on Tigers and King Tigers to producing more Stogs and Panzer IVs, they would have had more armored vehicles available more often. This wouldn't have won the war, but it would have made German defenses more formidable and possibly prolonged the conflict. The obsession with technical superiority and super weapons like the Tiger diverted resources from more practical options. It's worth noting that some German tank designs were actually quite good. The Panzer IV, which entered service before the war and served throughout it, was an excellent tank. It was reliable, could be produced in reasonable numbers, was mechanically sound, and was continuously upgraded throughout the war to remain competitive. If Germany had focused its efforts on producing more Panzer IVs rather than chasing exotic heavy tank designs, it would have been better served. The Panzer IV had some 9,000 units produced during the war, a respectable number, though still dwarfed by Allied production. Its operational readiness rates were generally good, and it formed the backbone of many panzer divisions. It wasn't as impressive as a Tiger or Panther, but it worked. Similarly, the earlier mentioned Stug 3 was an excellent vehicle. The lesson here is that Germany was capable of producing effective, reliable armored vehicles. The failures came when the pursuit of technical perfection overrode practical considerations. German engineers could have built German T-34, reliable, simple, mass-producible tanks. They chose not to, and that choice had consequences. The Soviet approach to tank development is particularly instructive. Soviet tanks were not technically sophisticated. They were often crudely finished, with rough welds, Spartan interiors, and basic components. But they worked. Soviet design philosophy prioritized function over form, reliability over sophistication, and mass production over individual quality. Soviet engineers understood that a tank was a weapon meant to be used and destroyed, not a precision instrument to be preserved. T-34, that designed to have short service lives. They were expected to survive only a few months in combat. This allowed Soviet designers to eliminate anything unnecessary for that short lifespan, reducing cost and production time. This approach proved devastatingly effective. By 1944, Soviet tank armies were rolling over German defenses, not because individual Soviet tanks were better than individual German tanks, but because there were so many of them, because they kept running, and because destroyed ones were immediately replaced. Soviet tank factories produced up to 1,300 T-34s per month at peak production. German factories never approached such numbers for any single tank type. Let's discuss the myth of German tank superiority that persists to this day. Post-war accounts, particularly German memoirs, often emphasize the technical superiority of German tanks. These accounts influenced early histories of the war and persist in popular culture. But they're misleading. Yes, a Tiger could destroy multiple Shermans or T-34s if properly positioned and supported. But combat isn't a series of isolated duels. Combat is about logistics, reliability, availability, numbers, combined arms, air support, artillery, infantry, intelligence, and doctrine. In all these areas except individual tank-on-tank combat, Allied forces had advantages, often enormous ones. The myth of German superiority also ignores the human cost. German tankers were often superb, well-trained, experienced, and brave, but they were let down by their equipment, by strategic leadership, and by an economic system that couldn't match Allied production. Individual acts of courage or tactical brilliance couldn't overcome fundamental systemic failures. A single Tiger might knock out 5 enemy tanks, but if that Tiger then breaks down and is abandoned, if its crew is killed or captured, and if it can't be replaced, what has been achieved? Post-war analysis by Allied intelligence officers who studied captured German tanks reached some interesting conclusions. They noted the sophisticated engineering, but also the impracticality. One report on the Panther noted its excellent firepower and armor, but called its transmission a disaster and its final drive inadequate. A report on the Tiger called it impressive but impractical for mobile warfare. American engineers testing captured German tanks were often baffled by the complexity. One engineer examining a Tiger's transmission asked why anyone would design something so complicated for a combat vehicle. The answer, of course, was that German engineers were designing for technical excellence, not for the messy realities of mass production and field maintenance. There's a German word that encapsulates this, Verschlimmbesserung, which roughly translates to an improvement that makes things worse. This perfectly describes many aspects of late-war German tank design. Attempts to improve tanks by making them heavier, more heavily armored, and more powerfully armed made them worse by making them unreliable, immobile, and impossible to produce in adequate numbers. Let's consider some specific statistics that illustrate the scope of German tank failures. In the invasion of Normandy, German forces had approximately 2,300 armored vehicles of all types available, including tanks, assault guns, and tank destroyers. Allied forces had approximately 4,000, so the Germans were outnumbered about 2 to 1. But operational readiness rates meant that of those 2,300 German vehicles, only about 1,200–1,400 were actually operational at any given time. Allied operational readiness rates meant that of their 4,000 vehicles, some 3,000–4,500 were operational. Suddenly the real ratio wasn't 2 to 1 but closer to 3 to 1. And these numbers only got worse for Germany as the campaign progressed. After 3 months of fighting in Normandy, German panzer divisions had been shattered. Many had lost 80–90% of their armor, with the majority abandoned due to mechanical failure or lack of fuel rather than destroyed in combat. The Allies lost plenty of tanks too, but they were replaced. By September 1944, Allied armored forces were actually stronger than they had been in June. German forces were shadows of their former selves. On the Eastern Front, the numbers were even more dramatic. In 1944, the Soviet Union launched a series of massive offensives that destroyed German Army Group Center and pushed German forces out of most of the Soviet Union. These offensives, such as Operation Bagration, saw Soviet tank armies smash through German defenses. While German heavy tanks occasionally inflicted severe losses on attacking Soviet forces, they couldn't prevent breakthroughs. There simply weren't enough of them, and those that existed couldn't be supplied or maintained. Soviet armored forces accepted heavy losses, but kept coming. German forces, once overrun, couldn't recover. A typical Soviet tank army might lose 30–40% of its strength in an offensive, but receive replacements within days or weeks. A German panzer division that lost 30–40% of its strength might wait months for partial replacement, if it came at all. By 1945, many German panzer divisions existed only on paper, with a handful of operational tanks and combat strength measured in the hundreds rather than thousands of men. The names remained 1 Cent SS Panzer Division, Panzer Lehr Division, but the reality was hollow shells unable to affect the war's outcome. One of the most telling indictments of German tank design comes from examining what happened when Allied forces captured German tanks and tried to use them. American and British forces occasionally captured Panthers or Tigers in running condition and attempted to use them. The results were almost uniformly negative. Captured Panthers invariably broke down after short distances. The complicated controls confused Allied crews accustomed to simpler tanks. Maintenance was nearly impossible without specialized tools and knowledge. Fuel consumption was prohibitive. In almost every case, Allied forces concluded that captured German tanks were more trouble than they were worth and abandoned or scrapped them. Some were sent back to testing facilities, but few, if any, were used operationally for any length of time. The Soviets also captured thousands of German tanks and generally reached similar conclusions, though they did press some into service out of desperation. If these tanks were truly superior, surely Allied forces would have eagerly used them. The fact that they didn't speaks volumes. There's one more factor worth considering: the psychological impact of failed designs on German decision-making. By late 1944, German military leadership knew the war was lost. Yet resources continued to be poured into increasingly absurd projects like the Maus super heavy tank or various proposed superweapons. Why? Partly because the Nazi leadership, particularly Hitler, was detached from reality, but also because there was a sunk cost fallacy at work. Germany had invested so much in the heavy tank concept that abandoning it felt like admitting failure. So resources kept flowing to projects that had no hope of affecting the war's outcome. Meanwhile, more practical needs went unmet. Infantry divisions were understrength and poorly equipped. The Luftwaffe was short of fuel and pilots. The Navy was barely operational, but precious steel, labor, and engineering talent went to building a 188-ton tank that couldn't cross bridges. This wasn't just bad design, it was a systemic failure of strategic thinking that reflected the broader collapse of Nazi Germany. In conclusion, German tank designs failed under real combat conditions because they prioritized the wrong things. They prioritized technical sophistication over reliability, individual superiority over mass production, and theoretical performance over practical logistics. These failures were rooted in a broader German strategic failure, the belief that superior technology and tactics could overcome material disadvantages. This belief was wrong. Wars of this scale are won by economics, production capacity, logistics, and the ability to replace losses. Germany couldn't match Allied production, couldn't maintain supply lines under air attack, and couldn't replace its losses. Designing ever more complex tanks didn't solve these fundamental problems, it made them worse. The Panthers, Tigers, and King Tigers that have achieved legendary status were ultimately failures. Not failures of engineering, they were marvels of engineering, but failures as weapons of war. A weapon that doesn't work reliably, can't be produced in sufficient numbers, can't be supplied and can't be maintained is a bad weapon regardless of its theoretical capabilities. German tank designs looked impressive on paper and in propaganda photos, but in the mud, snow, and chaos of actual combat, they failed. The Allies understood this and designed accordingly. That's why they won. The legacy of German tank design is complex. Post-war, many nations studied German tanks and incorporated some elements into their own designs. The emphasis on powerful guns and heavy armor influenced early Cold War tank development. But the lessons about reliability, logistics, and production were also learned. Modern main battle tanks attempt to balance firepower, protection, and mobility while maintaining reliability. The over-engineering that characterized late-war German designs is generally avoided. Modern military planning emphasizes logistics and sustainability in ways that German planning did not. In that sense, German failures taught valuable lessons. But in the context of World War II, German tank designs failed. They failed their crews. They failed their strategic objectives, and they failed to prevent Germany's defeat. The myth of German tank superiority persists, fueled by impressive specifications and dramatic stories of individual combat actions. But the reality is that German tanks were expensive, unreliable, over-engineered machines that couldn't be produced fast enough, couldn't be supplied adequately, and couldn't change the war's outcome. That's not legend, that's history. Thanks for watching. Please subscribe and share.